Hello, welcome to Olympiad geometry. Let's continue our learning of the Menelaus theorem. Here is a problem. Circle O1 and circle O2 are tangent to all three lateral lines of triangle ABC. E, F, G, H are tangent points. Line EG intersects with line FH on point P. Prove PA is perpendicular with BC. A very straightforward thinking is that we can extend the PA to line BC, assuming that the crossing point would be D. So we want to prove that the angle FDP or angle BDP is 90 degrees. But it's very difficult to prove that because D comes from the extension of PA and A from tangent line, P from tangent point extension line. It's difficult to relate P with A together to find the angle of FDA. So for this problem, if we look at the figure, we can sense that there's some similarity from the left side and the right side. On the left side, it's a circle, and on the right side, it's another circle. So we can think about how we draw this figure first. Of course, we can draw the figure in the sequence of the condition, like we have a ABC first, then we extend the AB line, AC line, and BC line, find the circle that tangent with these three lines. Or we can draw two circles first and find the tangent line. Why it matters? Because for the second drawing sequence, we sense a similarity on the left side and the right side, which means if we want to prove PA is perpendicular with BC, we rather to do it in a reverse way, that we find the perpendicular line first, and then we prove that perpendicular line of AD is a line PA. So we can draw the perpendicular line from A to BC as AD, right? Let's do this. So draw AD perpendicular with BC and intersects BC on point D. So now we have this perpendicular line first. So we have this 90 degree first. And then we just need to prove that DA through the P, right? P is on the line DA. We just need to prove that. But we can find it's also difficult to prove because P comes from the intersection point of EG and FH, not on the DA. So we do this. We find intersection point of line DA and line FH. Call this point as P prime, right? And we can find, so we find the crossing point of DA line and FH. We call it P prime. And then we find intersection point of line DA and line EG, we can call this point as P double prime. We find another point of the intersection for the line DA and EG. So basically we here called P prime, and for another line, for another point, we can call it P double prime. Basically we want to prove that P prime is the same point of P double prime, right? Because if P prime is the same point of P double prime, that means EG intersect with FH on the point P, but this point P also intersect with DA, right? This point P is also the intersection point of DA line and FH line. That's P prime. So P prime, P double prime, they're the same point. To prove this, we can find, if we have a way to show that this segment relationship, like I just write it like this way: AP prime divided by, for example, DP prime equals to AP double prime equals to DP double prime. Then we can prove that P prime is actually same as P double prime. So how can we have this kind of equation that including the AP or DP here? We want to know the ratio. This is a sign that we can try to use Menelaus theorem to find a ratio including this line. So assuming that we want to find a line that including this line, means this line must be a lateral of a triangle, and either D or A or either D or A are the convex of the triangle, because from the Menelaus theorem, we always start from a convex and goes to the intersection point, and then start from the intersection point to another convex, right? So here we have the point P reused from the numerator to denominator, which means P prime must be an intersection point rather than a convex, which means D and A should be the convex of that triangle. And we know that we want to prove left half and the right half because we want to prove AP prime, DP prime, and AP double prime, DP double prime. Means that we need to find the triangle from the right half or the left half. That gives us very limited choice, because if you think DA as a lateral of a triangle and we want to find the intersection point P, that means we can only choose the triangle DCA. So let's use Menelaus theorem on triangle ADC and line FH. Oh no, this triangle, and on the line of EG P prime, P double prime. So start from a convex, that's A, G, divided by CG. AG divided by CG times CE divided by DE times D double prime divided by A double prime. DP double prime divided by AP double prime. This equals to 1. That's for the right half. And for the left half, we can use Menelaus theorem on the triangle ABD and the line FHP prime. Right? So we got AH, right? The triangle ABD under the line FHP prime. So AH divided by BH times BF divided by DF times DP prime divided by AP prime equals to 1. So let's simplify these two equations. First, we notice that CE is a tangent line of the circle O1, and CG is a tangent line of the circle O1. So these two terms cancels. That means we have AG divided by DE equals to AP double prime divided by DP double prime. That's from the first, we call this as the first Menelaus theorem equation. And we got similarly, BH is a tangent line of O2 and BF is a tangent line of O2, right? So BH equals to BF. And we got AH divided by DF equals to AP prime divided by DP prime. This from the second equation of the Menelaus theorem. So we want to prove that AP double prime divided by DP double prime equals to the ratio of AP prime to DP prime. We just need to prove that AG divided by DE equals to AH divided by DF. Now we look at the figure AG divided by DE equals to AH divided by DF. Right? AH, DF, AG, DE. So what is H point? What is F point? That's the thing we need to figure out, because we have the ratio of AH divided by DF. So if we do this, we connect O2 to H and we connect O2 to point F. We know that O2H is perpendicular to the line AH. O2F is perpendicular to the line DF. And let's call the radius of the circle O2 is R2 and the radius of the circle O1 is R1. We do the same thing for the circle O1, that we connect O1G and O1E. So we know that O1G is perpendicular with line AC or AG. O1E is perpendicular to the line DE, right? This is 90 degree, this is 90 degree, and here is 90 degree. So we notice that because AG is a tangent line for circle O1 and AB is a tangent line for circle O1. Similarly here, AH, that's actually BA line. is a tangent line of circle O2, and the GA line also the tangent line of circle O2. So if we connect O1 to point A, we know that O1A, so the angle O1AG equals angle O1AB. Right? Because because AG and AB are tangent line of the O1, so O1A is an angle bisector of angle BAG. So we got this. O1AG equals to O1AB equals to half angle GAB. And if we connect point A and point O2, we notice that O2AH equals to angle O2AC equals to half of the angle CAH. And because the angle GAB equals to the angle CAH, that means angle O1AG equals to angle O2AH. And we know angle O2HA and angle O1GA are 90 degrees. So the triangle AGO1 is similar to triangle AHO2. Also, we know that because this angle, this angle, this angle, and this angle, they are all equal, means O1, O2 are collinear. And because we got AD is perpendicular with BC, O2F is perpendicular with BC, and O1E is perpendicular with BC. So AD is in parallel with O2F and in parallel with O1E, right? These three lines, they're in parallel each other. So from the first condition, we got, because they are similar, so we got AG, the ratio of AG to O1G equals the ratio of AH to O2H. And from the second condition, right, these three lines, they are in parallel with each other, and O1, O2, we can think as O1, O2 intersect with these three parallel lines. EF intersect with these three parallel lines. So we got O2, we got O2A, the ratio of O2A to O1A equals to the ratio of DF to ED. Here we have another ratio. Because of the triangle AGO1 and AHO2 are similar, so actually we want to have the ratio here as AG to O1A equals to the ratio of AH to O2A. Now we look at the original equation we want to prove, right? We want to prove we want to find the ratio of AG to DE. So we can have AG to DE here. It equals to AG to O1A times O1A to DE, right? We can split this AG to DE into two ratios. And because AG to O1A equals to AH to O2A, so we write it as AH to O2A. And O1A to DE equals to O2A to DF, O2A to DF. So that means these two can cancel each other. We got AH to DF. We prove it. Right? So we prove that the ratio AG to DE equals to the ratio AH to DF, which means AP double prime to DP double prime equals to AP prime to DP prime, which means P prime and point P double prime are the same point. And this point is point P. So this problem is not very easy, but this problem is very interesting to show us that how we prove two lines are perpendicular. Basically, we can use proof of contradiction, and we can find, especially for this figure, right, the left side and the right side has some similarity. So we can use a method of proof of contradiction, and then we can set P prime first. We can set like a right part first and find some relationships, and then find the left part relationships, and then find a way to connect them together. Here the way is that AP prime to DP prime and AP double prime to DP double prime. Once we find that, we can eventually get the proof we want. Okay, that's for today's video. See you in next video. Thank you.